19, we're going to get some number out, right? Like something close to 1, right? That's called, putting it in there is putting it into the activation function. Okay, so the neuron, he says, takes the sum that we said, like these two white lines give us this 19. Okay, so it takes the sum and we put it into the activation function and we get something out, right? So that's called the activation function.
Well, so circles represent neurons and lines represent synapses. Synapses have a really simple job. They take a value from their input, multiply it by a specific weight, and output the result. Neurons are a little more complicated. Their job is to add together the outputs from all their synapses and apply an activation function. Certain activation functions allow neural nets to model complex, nonlinear patterns that simpler models may miss. For our neural net, we'll use sigmoid activation functions. Next, we'll build out our neural net in Python.
Okay, so that's the idea of building it, of discussing okay, next he's going to do the Python.
森光一郎です。Wix で自分のサイトを作ってみました。Wix.com に
Last time, we set up our neural network on paper. This time, we'll implement it in the programming language Python. We'll build our network as a Python class, and our init method will...
Okay, so in programming, we learn how to build what are called classes. So that's just like how to organize all of this into something that's sort of that's organized. Okay, so but it's a very good way to solve it, to work the problem. Okay, so he's doing that now. So some of these details are not going to be that clear because
we'll take care of instantiating important constants and variables. We'll make these values accessible to the whole class by placing a self dot in front of each variable name. Our network has 2 inputs, 3 hidden units, and 1 output. These are examples of hyperparameters. Hyperparameters are constants. This allows for big computational speedups, especially when using tools like MATLAB or NumPy.
Okay.
Our inputs are weight matrix.
Okay.
Using matrix won't the complicated operation, but if we take the 3 outputs, it needs to be multiplication 3 by 2.
Okay.
Doing this allows for big computational speedups, especially when using tools like MATLAB or NumPy. Our input data matrix X is of dimension 3 by 2.
Okay, so how many people have worked with matrices before? How many people have, you know how to multiply 2 matrices or not? No? Okay, let's stop and talk about that. That's a subject that we used to cover in this class, sometimes. So no harm in doing it now. So let's talk about matrix multiplication. This is a matrix. This is called a vector. Okay? So, but this can also be thought of as a matrix. So we have 2 matrices and we can talk about multiplying them. So let's see what we mean by that. So let's take a matrix like this. So okay, so this is a matrix, and we talk about the size of the matrix. So how many rows are there in this matrix? How many rows? 1, 2. There's 2 rows. How many columns? 3. So we say that we say this is a 2 by 3 matrix. We always say the rows first and then the columns. Okay, so this is a 2 by 3. On the other hand, this is another matrix, and that's what size? So if you say the rows first, it's a 3 by 2. Okay, everyone agree? All right, now suppose that we have, then what about this? Yeah, okay, suppose you have this 1, 2, 2, 3. How big is that? 2 by 2, right? Suppose we have another 2 by 2, 0, 1, 2, 0. Suppose you have that. Okay, that's also 2 by 2, right? We talk about, we can call this one A, and call this one B. Okay? We can talk about adding 2 matrices, just like we can add numbers. So when we add two matrices, what we do is we add them element by element. So I'm going to get, if I add them element by element, what am I going to get? 1.
3,
How about here? 3. How about here? 4 and 3. Okay, so it's easy to add matrices, right? And subtraction is the same thing. Now you can't add this one and this one because they're not the same size. We don't talk about adding two matrices that don't have the same size. Okay? So, however, and a vector is also a matrix. A vector, like this, for example, 1, 2, 5, like that. That's, if you want to say that's a matrix, how many rows are there?
3 by 1.
3, so it's a 3 by 1. So a 3 by 1 matrix is also a vector, and also a 1 by 4 is also a vector. Okay, but just you have to keep the bookkeeping straight, but basically they're vectors. Okay? Now, okay, so it's clear what we mean by adding and subtracting. That's simple. Okay, those definitions are simple. We say we add element by element. Okay, however, multiplication, you might say, well, maybe multiplication, let's say I want to multiply these two. Naturally, a natural thought would be to do what? Same thing, element by element. Okay, but that's not the commonly used multiplication. Sometimes that's useful, but rarely. It's not very, it has a special name called the Hadamard product, but it's hardly ever used. It's just one time out of 100, you're going to do that kind of multiplication. So that's not what you do. So what you do is kind of messy and complicated. Did you learn this or not? So, okay, so first of all, when you multiply matrices, so this is a 2 by 2, and this is a 2 by 2. So this is okay to multiply these two, but in general, this number has to match this number in order to multiply. It doesn't matter about these numbers in terms of whether or not you can multiply, but these two have to match. So I could do, in fact, I'll just change it. I'll do a 2 by 3. So 2 by 3 means 2 rows, but 3 columns. So I'll do that. 2 rows, but 3 columns. Okay, let's make them not too hard. 1, 0, 1, 1, 2, 1. Okay? Okay. Now we're allowed to multiply these because this size is what? How many rows? 2 by 3. As long as these match, we can do this multiplication. Now the question is, what kind of result? How big is what's the size of the result? Is it going to be a 2 by 3? Is it going to be a 2 by 2? Is it going to be something else? It's going to be, the size is going to come from this and that. So the size is going to be what? In this case, 2 by 3. Okay? So these have to match to do the multiplication, and then the result, the size comes from the outside too. Okay? Is this clear? Okay, now how do you get these? So already though, I know that the result is going to be a 2 by 3, so it's going to look something like that. Right? Okay? Okay, so that means there's going to be how many entries in this matrix? 2 by 3 means there's going to be 6 entries. Right? So let's just draw a line for each one. This is going to be one of them, another one, another one, another one, another one, another one. So we have to fill these in, right? So how do you do it? The way you do it is, so how am I going to get this entry here? So this is called A, this is called B, and let's call this C. Okay? Now, first of all, it might be useful to use a notation for, like, this element here, we'll refer to it as A, because this is the matrix A, so I use A, but this is in what row and what column? What row is this in?
Second.
Second row. What column?
First.
So we call it A21. On the other hand, this one, this is going to be called B something. What row is this in? 1. What column is it in? 3. So we're going to call it B13. This one, we're going to call it B something. B21. Okay, so these subscripts help us to keep things organized. Okay? So again, whenever you write a subscript, you write the row and then the column. Okay? The row and then the column. Okay, so this one I could call, let's say this one, I'll call it C what? C13. Sorry. 2, 1. Right? 2, 1, right? So the second and the first column, right? Okay, now how do we get C21? Okay, so this is the complicated part. So what you do is you have to take the second row from here and the third column from there. Okay? So that's first we're going to start with those. And then what we do is we take the first element in here times the first element in here, and then we take the second element in here times the second element in here. So what does that mean? What am I going to put here? It's going to be the first element there times the first element there. So what's that? 2 times 1, right? Right? And then plus, I don't have any more colors. I'll use this. Plus the second element there times the second element there. So what's that going to be? 3 times 1. Okay? And that's what this element is going to be. Okay? How about this element here? First of all, what should I call this element? See what? What row is it in? 2. What column is it in? 3. So it's called, we label this C2, 3. Right? Row, column. Right? Okay, how are we going to get it? So we're going to take the second column. Wait, did I do something wrong? What did I do wrong?
Should be
I did it wrong.
the first row of the first column of B.
Sorry about that.
Sorry, Professor.
I apologize.
C2.
I hate doing that on the first time through. That's a big, terrible thing to do. Anyway, I made a mistake. Okay, what did I do wrong? We're going to take the second row. I said times this column, but I meant the first column. First column. Okay, sorry. So it's not this column. So let's do it again. It's going to be times. So C21, we're going to take the second row times the first column. Okay, so it's not going to be 2 times, it's going to be 2 times 1. Oh, it is. No. Oh, it's the same. Okay, I was lucky, but not really. Okay, how about this? C23. So what's this going to be? The second row times the third column, which actually gives us the same thing again, right? So this is still, going to be 2 plus that, right? Okay, how about this one? What's that going to give? How am I going to do that one? Well, what element is that? C 1, 3, right? Okay, so it's going to be the first, so actually you can get it from here. You take the first row times the third column. The first row of the first matrix times the third column of the second matrix. So what is that? The first row is here times the third column, right? Okay, so it's this one and that one. Okay, so this multiplication is pretty tricky, right? A little bit tricky anyway, right? But this is how we define multiplication of two matrices. Let's just finish this one. What do I put in here? 1 times 1 plus 2 times 1. Is that right? I think that's right. Okay, so then we could fill in this and this and this, and we'd have the answer. Okay, is this clear? Okay, so that would be so we would say that A times B is equal to C. Okay, and that's called matrix multiplication. Okay, and for some reason, that's much more useful than the other thing that we could have done, which was just take the first element times the first element, and the second times this element, which would be a much more simple, natural way to define multiplication. But this turns out to be much more useful. Okay, so anyway, that's how we define matrix multiplication. So once again, these two have to match to multiply matrices. And then the size of the resulting one, a matrix, will come from the outside elements, the outside dimensions. Okay? Is this clear? Okay, so now, actually, to see why I said this turns out to be more useful, we can see an example of where it turns out to be more useful right here in this neural network problem. Because what happens if, first of all, let's try it. Let's define the first matrix here. What do we call that? X. So X is equal to what? Sorry, 4, 7, 3, 8, 5, 4. Okay? And what's the dimension of X? How many rows? 3. And how many columns? 2. X. 3 rows, 2 columns, right? Everyone agree? So this is a 3 by 2 matrix, right? Is that clear? Are we finished? Okay, is this clear? You're with me or not? Okay? And let's define Y as 89, 64, and 72. What are the dimensions of Y?
3 by 1.
Yuck. What is it?
3 by 1.
3 by 1. Is that right? Yeah. Okay. 3 by 2. 3 by 1. Oh. Yeah, sorry. Oh, no. Yeah. Oh, sorry. Okay, yeah, that's correct. But, sorry, I don't want Y. And I shouldn't call this X. Yeah, I'll call it X. Okay. However, okay, I erased the network. Okay, let's go back to here. Let's make this network again. 1. Okay, maybe this won't be too much work, but let's see if we can do it. So this is a lot. I mean, I don't mean to say that we can cover this in this class. I'm just trying to give you an idea. Okay. Okay, now let's label these again. Okay, remember we had numbers here, right? Okay, but we're going to call them W's, weights. Okay, so what I'm going to do is I'm going to call this W11. Okay, now I just have to do this right. So this one, I think, because it comes from here, and this one because it goes to here, or is it the other way around? That's what I forget right now. Let's see. Yeah, so this one, my question is this W12? Do I want to label it like that, or do I want to label it W21? I forget, so I think, let's see, let me think. IJ, so I want, I think this is right. I might have it just backwards. I might want to call this W, like put this node for the first subscript and put this node for the second subscript, but I'm not going to do that. I think it's this route. You see what I'm thinking about? I'm saying that this comes from the fact that I'm coming from the first node, and this comes from the fact that I'm going to the second node, but I forget if it should be reversed, like whether this should be called W21 or W12. Okay? So I just forget that, but I hope that I got it right. Okay, so this one is W. What if I'm doing it the same way? This is going to be W13, right? Okay? If I'm doing it the same way as these. So what do you think I'll call this one here, this W? W21, if I'm not right, if I'm not wrong. Okay, and this one is going to be called what? W22, and this one, if I'm doing it right, is W23. Okay? Okay, so how many weights do we have? We have 6, right? Okay, so we're going to put those into a matrix. Now, as I said, I can't remember if I did this right or not. Okay? So, but I'll try, I'll put it in. So if I did it right, then we have, what's the size of our matrix going to be? We're going to have W1, W2, and W1 and W2, right? So we're going to have, and that's the rows. So we're only going to have 2 rows. So it's going to be a 2 by 3, I think. So this is going to be W. What do we have? W11. Then we have W21.